We have one last example. Suppose we would like to fence in a backyard in the shape of a rectangle using only 120 feet of fencing, and we're going to fence all four sides. What I'd eventually like to do is find the maximum rectangle, maximum area I could actually fence in, but let's kind of take this in smaller steps. Part A, what is the equation for the area of this particular rectangle in terms of the letter L? Well, if I take a look at this rectangle, I'm just going to draw myself a little picture here, and I've put on two lengths and two widths, and I know the area of a rectangle is length times width, and I also know I have 120 feet of fencing, so I would actually know that 120 would actually have to be equal to the perimeter, and the perimeter formula, remember, is twice the length plus twice the width. So that gives me a second formula I'm going to use, and I could actually simplify that formula because everything there is divisible by 2 in that second equation. So I actually could say 60 equals the length times the width. Halfway around is length plus width, right? And so that would be 60. Now remember, my goal is I want to write the equation for the area in terms of L. And I know area is LW, so what I want to do is get rid of the W. So what I'm going to do is solve for it. So if I do that, I get W equals 60 minus L in that second formula. And so then I can take that information and take it back to my area formula. So area is length times width. That would then be L times 60 minus L, or in other words, 60L minus L squared. So now I have written the area in terms of only the L. Now, I'd like to find the dimensions that maximize the area. Well, notice if I look at my equation, the squared term's negative, so I have a parabola that's concave down, it opens down, and so the vertex is the maximum. So if I'm looking for dimensions that maximize the area, I'm looking for the vertex or something related to the vertex of that particular function. So if I do that, instead of, again, x equals, this is L equals, because L is my variable, negative b over 2a, so that's going to give me negative 60. My b term, remember, is the coefficient of L, not just the second term, it's the coefficient of L. So that would make it negative 60 when we get done, multiplied by, or not multiplied, divided by twice the a term. The a term coefficient would be negative 1, so 2 times negative 1. And when I do the math out, I get 30. So the length that's going to maximize the area is going to be 30 feet. And I can go back and then plug that in and find that the width is also going to be 30 feet. What this tells me, and it's one of these well-known mathematical facts, that if you fence something in using all four sides of fencing, it's not true if we only fence in 3 sides. If we fence in all 4 sides, the maximum area that you can create will actually be the area of the square. So if I have fencing and I wanted to get a maximum area, suppose I have my dog and I want to give him a pen, I'm going to give him the most space, the most area, if I create the pen in the shape of a rectangle, if I'm fencing in, or in the shape of a square, if I'm fencing in all 4 sides. A little bit different if I'm fencing in 3 sides, if, say, one side is my house. But when I do all 4 sides, the maximum area would actually be a square. Now you can go on and take a look at a number of the problems in the textbook for this section. Some of them are a little bit more challenging, and we may need to talk about them in class.